Happy Wednesday, everybody! Welcome to day 3 of the instantaneous rate of change lesson, where the only thing constant in life is change. And that's what mathematics is all about, is measuring change. And we've been studying about measuring change since the beginning of the year. So if we go on to our next slide here, we've been learning about instantaneous rate of change and how we can determine what is the change at a single instant in time. And so what we began with is the secant lines. And then as our secant lines get progressively closer and closer together to a single point, we can determine the instantaneous rate of change, or the change at that one moment in time. But let's ask ourselves the question, what if I wanted to know my rate of change here at D and at C and at B and at A as well? What would I have to do? Well, with what I know right now, I would have to make a series of secant lines to each of these points and set up intervals at each of these points and insert x values into the function for each of these points, and then decide what the rate of change is by using my slope formula. And quite frankly, that would be a lot of tedious math work. And it would even be a lot of work with the spreadsheet calculator like we have been using. So the question is there an easier way than constructing intervals? And yes, there is, by finding the derivative of the function. So what is the derivative of a function? The word derivative is a new function that gives you the instantaneous rate of change at each point of the old function and the slope of the tangent line for each point on the curve. So today we're going to learn about the first part of our definition of a derivative, is developing that new function. And then Thursday, we will get into using that new function to determine the slope of the tangent line for each point on the curve. So, included with your Google Classroom assignment today is a sheet called the derivative of a polynomial function. And as we see here, the standard form of a polynomial is f of x equals ax squared plus bx plus c. And then here there's 4 rules that we're going to use. And these are derivative rules that we're going to use to rewrite the polynomials that were given into a new function, or basically to derive a new function from the old function. All right, so these are the rules that we're going to learn, and I'm going to explain them to you. All right, so if we look here, I wrote the 4 rules here on my Canvas pad, and I'm going to write a polynomial function over here, which is going to be f of x equals x squared plus 4x plus 1. Now, each of these rules off to the left are going to apply to a particular term inside of this function. Now, when we write our new function, or the derivative, we're going to call the derivative. We put a little symbol up there, which means f prime, which means it's the derivative function. So if I look over here at my first term, I have x squared. If I look up here at my first rule for the a term, it says that this d over dx means the derivative of x to the n power. So whenever I have a term that is being raised to a power, I am simply going to take the value of that power and move it to the front of that term. And then I'm going to also simultaneously take that power and subtract 1 from it. So if I look here at my first term, which is x squared, I am going to take my 2 and move it into the front of x, which is going to be 2x. Then I'm going to take that same 2 and leave it in the exponent position and subtract it by 1. All right, so that's what I do with my first term. If I look at my second term, which is 4x, that's going to be my second rule, which is the derivative whenever I have a coefficient of x equals the coefficient. So here I have 4x that means the derivative of 4x is simply going to be 4. If I look down at the next rule, so that's my first rule, there's my second rule, my third rule doesn't apply here. And what this third rule simply says is the derivative of x equals 1. So whenever x is by itself without a coefficient, it's just going to be the number 1. And I will show you that in another example. So then if I look here at my next rule, the derivative of the constant equals 0. So in this particular polynomial function, my constant or my c term over here is 1, and that's just going to become a 0. So that means the derivative function of x squared plus 4x plus 1 is going to be 2x, and then 2 minus 1 is 1. So I'm just going to leave that as 2x plus 4. So this here is the new function using our function rules. Oh, excuse me, our derivative rules. Okay, so that's how you would write a derivative function. Now understand these rules are they're math rules, they're shortcut rules. Over here I have a picture of the long way to do it, which you will get to do this later on in your math career. And if we were in the classroom, we would certainly do it this way. I like doing it the long way. It takes up about a page of math, and you know how I love to do a page of math. But this is how you would do it without using the rules. So we're going to use the rules, and you will get to the longer way later on in your math career. All right, so let's do another example here. Our next example is going to be f of x equals x squared plus 3x plus 6. So again, if I'm going to find the derivative of this function or write a new function, if I start with my first rule, I have x squared. So I'm simply going to take the 2 and move it to in front of the x. So that gives me 2x. And then at the same time, I'm going to take the 2 and subtract 1 from it the way the rule says. Then for my next term, I've got the derivative of cx. So anytime I have a coefficient of x, that just becomes the coefficient. So that's going to be 3. And then x is not by itself. So then I look down to my final rule, which is the derivative of c, which is the constant, equals 0. So the 6 becomes a 0. So the derivative function of x squared plus 3x plus 6 is going to be 2x plus 3. Because again, 2 minus 1 is 1 in your exponent, and it's understood that that is going to be a 1 with the x next to the 2. All right, so we'll go ahead and we'll do another example. All right, so here I've got f of x is going to this time equal 4x squared plus 6x plus 1. So if I'm going to write my derivative function, first thing I look at is I have 4x squared. So my first rule is to move the 2 to in front here. So that's going to become 2 times 4 times x. At the same time, that's going to become 2 minus 1 here. Plus my next rule, which says if I have a coefficient with the variable x, that just becomes the coefficient, which is going to be 6. All right, x is not by itself. So then I have a constant, which is going to become 0. So 2 times 4 is going to be 8x. 2 minus 1 gives me that, again, that variable of 1 there. So I have 8x plus 6. So the derivative function of 4x squared plus 6x plus 1 is going to be 8x plus 6. right, then, so let's look at this one. This one is going to be 5x squared plus x minus 8. All right, so again, when I look at this, and I'm going to write my derivative function. So I start with my first rule. So I'm going to move my 2 to in front of the 5. So that's going to become 2 times 5 x to the 2 minus 1 for the first rule. Now, there is no coefficient of x this time, but x is by itself. So when x is by itself, that just becomes plus 1. And then the next rule is whenever I have a constant, it just becomes a 0. So the negative 8 becomes a 0. So this becomes 10x plus 1. Because for my exponent up here, 2 minus 1 is 1. And anything to the first power is itself. Okay, so these rules that I'm showing you will work with all kinds of polynomials, not just with these that are quadratic equations and that we see here. So for example, if I had a different kind of a polynomial that was f of x equals 2x to the 4th power plus 5x to the 3rd power plus x squared plus 2x plus 3, okay? Again, I would use my same rules to solve this kind of a polynomial as well and to write a derivative function of it. So if I start here, I move my 4 right there, so that becomes 4 times 2, and then you have x to the 4 minus 1, and then my 3 would move here, so that's going to become 3 times 5 to the x to the 3 minus 1. My 2 is going to move in front of that x, so that's going to become 2x to the to the 2 minus 1. And then, since I have here a coefficient of x, that's just going to become plus 2, and then that 3 is going to turn into a 0. This rule is not going to apply, so the derivative of the constant is going to be 0. So 4 times 2 is going to give me 8. X, 4 minus 1 gives me 3. 3 times 5 is going to give me 15. X, 3 minus 1 is going to give me 2. And then I have 2x. 2 minus 1 is 1. And then plus 2. So that would be my derivative function of the polynomial 2x to the 4th plus 5x to the 3rd power plus x squared plus 2x plus 3. All right, so I hope it's pretty straightforward and understandable to you. If it is not, please, 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 please meet me on Google Meet so I can go over it with you, because tomorrow when we go to writing the equations of the tangent lines, I'm going to expect you to be able to do this. Okay, so have a great day, everybody, and please come and see me on Google Meet or message me with any questions.